Time. Hey everyone, it's been a long time. If you have been wondering where you have been, life, learning, and growth happened. But today I'm back and we are starting strong. Let's talk about a simple topic, yet very crucial in building design, stairs. A stair is more than just a way to move from one floor to another. It's about safety, comfort, and good design. When designing a stair, we must consider the rise height, the tread width, stair slope, headroom, and of course, the building materials. A well-designed stair feels natural to walk on. A poorly designed one, you will feel it immediately in your legs and in safety risks. As you know, uh, as you are traversing from one step to another, if maybe the rise height is too long, you will feel uncomfortable. But when it is steady, one can traverse from one stair to another. Yeah. So in this building materials, one can use timber. Uh, of course, the most used one is concrete and sometimes steel work. So for today, we're gonna design a reinforced concrete stair slab. Yeah. So in the proto structure, stair is defined in two ways, or its design can be found in two areas. One is proto structure, where we do the modeling and uh, the the analysis, and this we have to go to the tab, the drawings and reports, and we can access the proto details from here. Stairs are always designed from the proto details. So we can access the proto details from the proto structure and then go to the drawings and reports tab. And then the other way we can obtain it from the uh, installed software, maybe on the desktop. When we are installing proto structure, we install proto structure, and then it comes with proto details and proto steel. So we can obtain the proto details using a shortcut. But for me today, I'm gonna use the one in the drawings and reports tab. So when I open proto details, click on proto details, it will first allow us to save this drawing so far, because the details it's gonna show out, there would be the drawings coming from this analysis of this drawing in the of this drawing in the working space. Proto details. So it is on this taskbar here. As you can see, it's opened here. When I minimize this, and we can be able to see this window for plotter details. As you can see, it is bringing the project title, which is in the plotter structure the other side. But of me now, I want to start a new drawing, not with the other ones from the other drawing I opened it from. So what I will do, I go to File and then open a new project. It takes a kinda good time to open. As you can see, the window is restricted for any or any choosing or any selection. As you can see, it asks us to maybe start with the template, but according to this, let's accept and go with this, because even the other side, when you are going to open it, it will ask you which project do you want to start with. So let me cancel this, and then I just auto generate drawings of the other building I was doing. So we'll maybe only allow maybe the form plan just for matter of time, and then draw. So the floor plan, first floor, and then draw. Ask me in the working space where I need to put my form plan. Just click in the space such that the drawings start to come on their own. As you can see, I had selected only one floor, and it has brought me the the rebars of this floor. Yeah, so stairs are designed as slabs. The reinforcement pattern is always of slabs. So stairs can be obtained from the design library of plotter structure or plotter details. Come to stairs, and it will open a window which type of stair to come out with. This one shows it is supported by the outer edge. As you can see, the red lines mean that it is supported on beams at the top and the bottom. We have this one supported at the outside edges. It can be supported by walls on both sides. We have this one supported at 3 edges, and then this one can be besides walls and then also beams. Also have the load bearing, and they are called separate steps. We have integrated steps, then spiral steps, mostly like in metallics, in steel design. For today, I'm going to talk about that which is supported at the outer side by beams, since it is the most common. Yeah, so in this we have to specify some of the parameters. One of the parameters includes the story height. In the beginning, we had to change the story height of the structure to our required values, and then we can change this one is editable to maybe 3200 millimeters. The default unit is millimeters. We have the stair width. The stair width it's from this one. Let's say from this line up to this line. Then the story landing width, which can be this one, this side. If I can maybe draw a stair, if I can maybe draw a stair, if I can maybe draw a stair, use maybe this pen. Yeah, this is the cross section through a stair. The landing means this. The width of the landing, they are meaning this. Then also this one is the landing. Then we can look at the stair height. Recall we have another going this side, so the story height will be moving from here up the top of here up the top of this story. And then we can have the stair. We can have the intermediate landing. This one is the same as this, the width. Then the plate thickness, meaning if we have our stair, uh, like this, sometimes we can draw the thickness of the plate, because we shall design this only the plate thickness, and then the other weight will be uniformly distributed to the thickness. As you know, only the rebars are found in the stair thickness, because if we have our stair maybe here, and this is the thickness, and then our rebars can run in this way and also in this way, but not on in the risers and the goings. Yeah, so our rebars will be found in only this plate thickness and not in the risings and the goings. Yeah, then the step rise, this one is identical, is known. The rise is this one, and this one is the going. And then as you can see, this is the rise and this is the going. Then the number of steps, are dependent on the rise and the width, I think. So maybe if we change this one to the going as maybe 300, and then come here, I think this one will remain as 18. But what about when we go to 400 and then click in this one? I see they remain 18. Yeah, this is the going. Then let's leave it at 300 and maybe change the stair, the rise here maybe to 180, and then as you can see it remains the same, but let's change it maybe to 240. As you can see, I think this one is not changeable. Maybe when we change maybe this one to 17 and then maybe click in this one, it actually specifies the step rise height. As you can see, I think I was not making it, but if we need maybe to change the number of steps, if we change the number of steps, the step height rise will increase. When we change it maybe to 20 steps, also this one will change automatically, as you can see. Yeah, and then the additional load, the variable load, 1.5 kilonewtons per meter squared is quite a big load, but we can change it. And then the live load, it's too much. Yeah, as you can see. Then the support widths, they mean maybe where the the stair is ending, where the stair is ending. My working space is maybe where the stair is ending. I can have this and then have my beam, and then here, and then yeah. So this is the support widths they are talking about. It can be a beam, can be a slab, and any of the support conditions. It can also be a wall, and as you know, the supports we have can be a cantilever, can be can be a simply supported, it can be that one restrained in all directions. Then we also have the support height. The support height is obtained from here. I change from the color, support height. This is our support height. Yeah, their meaning. So these ones enable us maybe to check for deflections, to also provide for the reinforcement in this stair slab. As I told you in the beginning, stair as designed as stairs are designed as slabs. Yeah, and also one-way spanning slabs. They don't have the reinforcement in both the x and y directions. They only have in one direction. Yeah, then after we have made our changes in this, what we do, we have to first redesign. After we have redesigned, it shows us the diameter of the bars and then detail. Or we can first have a report, can first design a stair report. First design a stair report. As you can see, it shows us the stair parameters, it shows us the deflection check, and then the loads, the serviceability loads, then the section forces, and then it shows us how the reinforcement will be. And then I can close this, then I detail my drawings. After I've clicked on detailed drawings, it will ask me where to drop my stair. I can drop it at that point by clicking at that point, and then you can see our stair being formed. Yeah, so as you can see, the reinforcement in this staircase, we have the longitudinal bars, which are these ones, 6H50 at 230 millimeters, and then we also have 20H8 at 220 millimeters. We have the distribution bars in both planes. It was this stair design was designed with 2 mats, but you can also design it with 1 mat. Yeah, so this is the stair design, and it can help you design your properties. Can help you design your stair in a well and comfortable design. As you can see, our going was 300, and then our riser was 218.2 according to the number of stairs. They have not defined the stair width here, but it is predetermined that it was 300 and then the height was 600. Yeah, so this is the design, and then we can continue to detail from AutoCAD. As you can see, these things cannot be seen properly and cause the line weight and then the other parameters, but we can export this stair to maybe AutoCAD and then make things visible as a competent engineer, such that they can be easily seen and then put into practice. Yeah, that shows the end of our stair design today. And then for comfortable stairs, proportion is key. The relationship between the riser, all those ones we have looked into them. But this is just a beginning. More stair details, design tips, and real examples are coming. If you found this helpful, like, share, and subscribe. I'm glad to be back. Let's build better step by step. If you want, I can also shorten it for stay step by step. Yeah. This remains GovCAD from GovCAD Engineering Solutions, Godfrey. If you want more practical design or one-to-one physical lectures, don't fail to hit me in the comment section. And in my bio, you can be able to see the email. Yeah, you can contact me on that email. Also on the numbers MTN and Airtel, I will be able to answer all your queries. Thank you very much for watching. Bye bye. Let's meet in the next video. Bye.